Let's do another problem. A calorimeter of negligible mass contains 1 kilogram of water at 303 Kelvin and 50 gram of ice at 273 Kelvin. Find the final temperature, uppercase T. We just use uppercase T as the final temperature. A calorimeter, you know what a calorimeter is? Of negligible mass means the heat absorbed by the calorimeter can be neglected. You need only look at the heat absorbed or liberated by its content. That is the meaning that the calorimeter has a negligible mass. Alright, what happens? Ice at 273 Kelvin first melts to become water at 273 Kelvin. The temperatures are given in Kelvin here. You see that? So ice at 273 Kelvin first has to melt to become water at the same temperature, absorbing a quantity of heat. What is the quantity of heat absorbed during that time? Will be mass times latent heat of fusion. Q1 is mass times latent heat of fusion. That will be, what is the mass of ice? Mass of ice is 50 gram. That will be 0.05 kilogram times latent heat of fusion is 3.34 times 10 to the 5 joules per kilogram per Kelvin. Now you see I haven't written any units for the quantities. Alright, you must know that this is in kilogram, this is in joules per kilogram per Kelvin. And that gives you 1.67 times 10 to the 4 joules is the amount of heat absorbed by ice. Let's do that on the diagram. Ice at 273 Kelvin melts to become water at the same temperature, absorbing this much of heat, 1.67 times 10 to the 4. And now what happens? Let us say, what are we supposed to find? Find the final temperature, uppercase T. So let us say that the uppercase T is somewhere here. That means this water at 273 Kelvin will now rise its temperature to this T Kelvin. So water at 273 Kelvin warms to become water at T Kelvin. What is the amount of heat absorbed during that time? Well, there is a change in temperature. Therefore, the amount of heat absorbed will be mass times specific heat times change in temperature. That will be Q2 is mass times specific heat of water times the change in temperature. 0.05, that is the mass of ice that is melted to become now water. Specific heat of water times the change in temperature. You see, initial temperature is 273. The final equilibrium temperature is this T. The change in temperature is T minus 273. Now that will be, multiply these two numbers, that will be 209 times T minus 273. And that is this quantity here. The amount of heat absorbed by water at 273 Kelvin to become water at T Kelvin is 209 times T minus 273. Alright, now we have 1 kilogram of water at 303 Kelvin. You see, the bucket contains hot water. Its temperature is 303 Kelvin. Now, it is now going to lose heat. From 303, it is going to come down to this T. Is that right? Alright, let's do that here. The total heat absorbed by ice will be this quantity plus this quantity. There you are. And that will be, I just distributed these in here. That gave me 209T minus 40,357. I just distributed this and added the numbers, and this is the result. And now water loses heat in cooling down from 303 Kelvin to T Kelvin. What is the heat lost by that water? The heat lost by water is mass times specific heat of water times the change in temperature. What is the mass of that water? 1 kilogram. The amount of hot water in the bucket is 1 kilogram times specific heat of water is 4,180 times the change in temperature. The change in temperature is from 303 to T. So that would be 303 minus T. And I distributed that and I got this big number minus 4,180 T. And now what do? The total amount of heat absorbed equal to the total amount of heat lost. Well, this is the amount of heat lost by the hot water. The total heat absorbed equal to total heat lost. That means this quantity equal to this quantity. What all you need to do is combine terms containing T, move this to the left and move this number to the right. We get 4,389 T equal to this big number. Well, that would be 1,306,897. Therefore, T equal to, divide the right side by this number, you get 297.8 Kelvin, and that is the final equilibrium temperature. Again, a very, very interesting type of problem, and you must be familiar with these kind of problems. Now, I think I have done a number of representative problems. I'm going to stop the lesson here. I have recorded this lesson as 2 parts. Remember, in the text, it is given as 1 lesson. Also in the PowerPoint, it appears as 1 lesson. But for the convenience of presenting it on lectures, I have divided it into 2.1a and 2.1b. So do the homeworks and get back to me if you need any assistance. I will see you for next lesson later on.